This summer, both professional and amateur astronomers around the world will focus on a small constellation deep in the night sky. But it's not the Northern Crown, the 7 stars of Corona Borealis, that's generating so much interest. There's a dark spot in that constellation where a nova event bright enough to be seen with the naked eye is about to occur. Dr. Rebecca Hounsell says, "This is a once-in-a-lifetime event that will create many new astronomers and give young people a cosmic event. They can observe for themselves, ask their own questions, and collect their own data. It will nurture the next generation of scientists." Hounsell is an assistant research scientist specializing in nova events at NASA's Goddard Space Flight Center in Greenbelt, Maryland. T. Corona Borealis, called the Flaming Star, and known to astronomers simply as TKRB, is a binary system located in the northern corona, approximately 3,000 light-years from Earth. The system consists of a white dwarf and a former red giant that is slowly being stripped of hydrogen by the relentless gravitational pull of its hungry neighbor. The red giant's hydrogen accumulates on the white dwarf's surface, causing pressure and heat to build. Eventually, it triggers a thermonuclear explosion large enough to blow off the accumulated material. For TKRB, this event appears to repeat on average every 80 years. Dr. Hounsell explains, "Don't confuse a nova with a supernova, which is a massive final explosion that destroys some dying stars. In a nova event, the dwarf star remains intact and ejects the accumulated material into space in a blinding flash. The cycle typically repeats itself over time, and this process can continue for tens or even hundreds of thousands of years. There are a few recurrent novae with very short cycles, but typically we don't often see a repeated outburst in a human lifetime, and rarely one so relatively close to our own system." Hounsell adds, "It's incredibly exciting to have this front row seat. Typically, nova events are so faint and far away that it's hard to clearly identify where the erupting energy is concentrated," Hayes said. "This one will be really close, with a lot of eyes on it, studying the various wavelengths and hopefully giving us data to start unlocking the structure and specific processes involved. We can't wait to get the full picture of what's going on." Some of those eyes will be very new. Gamma-ray imagers didn't exist the last time TKRB erupted in 1946, and IXPE's polarization capability is also a brand new tool in X-ray astronomy. Combining their data could offer unprecedented insight into the life cycles of binary systems and the powerful stellar processes that fuel them. Is there a chance September will come and go without the anticipated nova outburst from TKRB? Experts agree there are no guarantees, but hope abides. Don't forget to subscribe and hit the notification bell. See you in the next video.